Our problem statement is to write a program to find out sum of finite series. So what is finite series? A finite series is a summation of finite number of terms.
To understand this, let's take a simple example. Here we have four finite number, that is 5, 4, 3, 2. So its sum is 14. But the main question is how to do it in 8085 microprocessor. And that's a problem. Let's see its flow chart.
Initially, after starting, we load the HL pair with the address of counter and is moved to register C. Accumulator is initialized with 00H. Then HL pair is incremented to point to the first number in the array and it is moved to register B. Register B is added to the accumulator and the result is stored in the accumulator. Then the counter is decremented and check whether it has become 0 or not. If it hasn't become 0, it means there are number left in the array. In this case, the control jumps back to the increment HL pair and moves the next number to register B. This process continues until counter becomes 0. That is, all the numbers in the array are added. At last, HL pair is incremented and the result is moved from accumulator to memory.
Now, after knowing its flow chart, let's move towards the program and its working. Here is the program according to the flow chart. Now let's see how it is worked. First, we will take an array of size 0, 4, which means that it will have 4 elements. We will store this counter, which is 0, 4, at memory location D300. Then its element from D301 to D304. So first element is 05, next is 04, then 03 and last one 02. Now let's move to the program. First we will store the data, that is the memory location D300 to our HL pair. H consists G3 and L consists 00. Next, we will store the data stored at the memory location D300 to register C. Now register C becomes 04. Next, we will set the accumulator to 00. Then increment the HL pair by 1 and store the data to the register B. Now B becomes 05. Now we perform the AND addition operation, which adds A and B and stores the result into A. Now A becomes 05. Then we will decrement the counter by 1 and increment the HL by 1. Then we will store the data again into register B and perform addition operation and store the data into A. Again we will decrement counter to 02 until it becomes 01 or 00 at the end. Then we will increment the HL pair by 1, store the data at B, perform addition and store data or result into A. Again decrement C, which now becomes 01 but is not equal to 00. And then we will increment HL by 1, store data at register B, perform addition operation, store result into A, decrement counter by 1. Now we will see that the counter has become 0, which is a cue for us to stop the program, and hence the program is stopped here and the resultant, that is 0, is present at the accumulator. And our last instruction is STA D305, which means that we need to store the data of A at memory location D305. And the result of our whole program is 0E.
Then we stop the program. After understanding the working of our program, let's perform this program on DynaIDF as we cannot write a program. To perform this, we need a opcode of each instruction. So for our first instruction, the opcode is the 21 and the address 00D3. Then second instruction move C, M has the opcode 4E. Then MVIA 3E and then address. Then INXH has opcode 23. Then move B, M has 46. Add B 80. Decrement C 0D. Jump non-zero C2 and the address. Then STA 32 and the address 05D3. Then RST has opcode CF. After that,
Now let's see how it is being performed on Dyna 85 kit. Here is a small video. First, we will start the kit and see whether it's showing friend or not. Then set the address D400. This is our first instruction. Then second, third, fourth, fifth, sixth, then address seventh, eighth, its location ninth, and end of the program. Now we will store the array and its element. First, we will go to location D300, increment it and store the size 04, then its element 05, 04, 03, 02 and reset. Then we will execute our program which is located at D400 and press execute. As it is showing friend function when it's being successfully executed. Then we will check the memory location D305 for a resultant which is 0E. Hence we can say that our program is being successfully performed.
thank you.
Thank you.